Hello students, welcome back to Organic ChemVerse. In the last lecture, I have taught you what is hybridization in organic molecules. Today, we are diving into the various ways to represent organic molecules from simple chemical formulas to complex three-dimensional models. So let's get started. In organic chemistry, there are different ways of representing organic molecules depending on the need. We have different representations like complete structure, condensed structure, bond-line structure, and wedge-dash structure, also known as three-dimensional structures. We will discuss all these kind of representation in this lecture. First, a complete way of writing the molecules, which is also known as complete structures. A complete structure formula is a diagram that shows every atom and every bond within a molecule using lines to represent the covalent bonds. For example, in methane molecule, you see there is a carbon and 4 hydrogen atoms. The carbon is bonded to hydrogen through a covalent bond, sigma bond, right? So that's why we represent the bond as line. So we see here there are 4 bonds. Let's take one more molecule like C2H6. Since there are 2 carbons, connect the carbons, right? And carbon is tetravalent. Therefore, in order to satisfy the valency, write the hydrogens. You see, there are 6 hydrogens in the molecular formula as well as the complete structure. A molecule can even have a double bond, like in case of C2H4. Then how to write complete structures for such molecules? First, you write down carbon-carbon double bond and then you can write the hydrogens on the carbon like this. So you can observe carefully here, the carbon is bonded to 2 hydrogen and doubly bonded to the other carbon. That means the valency is still 4. Let's take one more example, that is C2H2, where the carbon is bonded to the other carbon with the triple bond. What about here? There are 2 hydrogen atoms on either side of the carbons. This is how we represent a triple bond. Now, we can even show a complete structure for heteroatoms. Heteroatoms means other than carbon and hydrogen, like oxygen, nitrogen, halogen, right? Let's take example of C2H5Cl, right? Chlorine is the heteroatom. In that case, you write down carbon-carbon chlorine, right? And then you have to place 5 hydrogens on 2 carbon atoms. We can even have a cyclic molecule. What does that mean? Say, if there is a molecule with the molecular formula C3H6, there are 3 carbons like this, and we have 6 hydrogens, right? On each carbon, you have to write 2 hydrogen to satisfy the valency of carbon. This is how we write the complete structures. Now, let's see what are condensed structures. Now that we have learned what are complete structures, let's see what are condensed structures and how to convert complete structures to condensed structures. The condensed structures are the representation of organic molecules without any bonds. We don't tend to show all the bonds present in the molecule. We try to write the atoms mostly as text in this case. What exactly it means? We have a molecule where 2 carbons are attached to 6 hydrogens like this. Then what we do is we'll club all the atoms, that is the 3 hydrogen atoms attached to this carbon, right? and we write it as CH3. And we are not showing any bonds between the carbon and hydrogen. Same here with carbon-carbon also. We club these three hydrogen and we will write it along with the carbon. So this is a simple representation of the ethane molecule, which is a condensed structure. We can even have a heteroatom. Heteroatom can be oxygen, nitrogen, sulfur, halogen, etc. In that case as well, we will cluster all these three atoms with the carbon, write it as CH3, and here we write it as CH2, right? And then chlorine as it is, like this. But if there is a double bond, it is always better to show the double bond like this. And then what about the hydrogen? Cluster them and write it as CH2, CH2. For the next molecule, right, you write the three hydrogens as CH3, right? And then for oxygen double bond, we tend to show that and hydrogen as it is. You should not take this hydrogen, right, with these hydrogens. No, that is not correct, okay? Because this hydrogen belongs to this particular group. So it has to be here. Same way for the next molecule. So it's CH3OH. This hydrogen belongs to this oxygen. So you have to write it with the oxygen. What about cyclic molecule? For cyclic molecules, you can't remove the carbon-carbon bond. Okay, you can't write like in the previous cases. You have to show the carbon-carbon bond because it is a cyclic structure. However, for hydrogens, you can write it like this. So this is how we convert the complete structures into simple condensed structures. So what are bond line structures? These are simple way of representing molecules where the bonds are written as lines. We tend to omit the atoms except for few atoms. So let's discuss that in detail. For the propane molecule, I have written a condensed structure, right? So that means there are 3 carbons. Each carbon is considered as a dot here, and then the bond between carbons are written as lines like this. And we tend to write these bonds in a zigzag fashion only. We don't write any carbons and hydrogen here, it is implied. So what does that mean? See, if I'm writing carbon here, that means what? There are 3 hydrogens here. It is understood. Same way here, there are 2 hydrogens and there are 3 hydrogens here. That's why the bond line structures are considered as much simpler and faster structures to write. Let's take the second molecule. You see there are 3 carbon, 1, 2, 3. You write down that either like this or like this. Okay, both are correct. Okay. Now on the second carbon, you see there is a methyl. So every carbon is a dot. So you see like this. But if you are writing the structure like this, upside down like this, then you have to write the methyl over here on the opposite. So you write either like this or like this. Both are correct. Okay. So let's take this molecule. 1, 2, 3, 4. There are 4 carbons. So 1, 2, 3, 4. Join these dots. You see on the second carbon, there is a methyl, right? Like here, like this. And here on the third also, there is a methyl. So make sure that the methyl is on the opposite direction of what we have here, like this. Don't write the structures like this. This is wrong. All right. So now let's move on to the next molecule where there is a heteroatom. You see there are 3 carbons. Okay. So 1, 2, 3, 3 carbons. And this carbon is attached to chlorine. So you have to show it as one bond. You can't write here. Okay. It is wrong. You write 3 carbon, extend the bond and then write the heteroatom. Okay. Now let's see if there is a double bond, how to write. No problem. You write down the carbons as dots in a zigzag fashion like this, right? And then between 2 and 3. So there is a double bond. So 1, 2, 3, 4. Between 2 and 3, double bond. You write that as it is. Okay. What if there is a triple bond? Whenever we have a triple bond, you have to remember that the sp hybridized carbon, it is linear in shape, because in hybridization you have learned the carbons which are sp hybridized must be linear. What does that mean? You write down a triple bond. The next to two carbons you must not write like this. Why so? Because just now I told it's because it's linear. So that's why you have to extend it like this, right? There is four carbon. There are four carbon, 1, 2, 3, 4, right? So this is how we have to represent the triple bond, right? Moving on to the next molecule. We have three carbons. So you write down three carbons like this. You can write like this time. Okay. Now, on the first carbon, there is a double bond oxygen. So oxygen you have to write because it's a heteroatom. And there is a hydrogen. So you have to write that also. Here we didn't write any hydrogens, but here we are writing. Why so? Because hydrogen belongs to a special group called as a functional group. So what is functional group? That we will be discussing in our next video. So for now, you just remember hydrogen, when it is attached to a group something like this, then we have to show that hydrogen. All right. Now, moving on to a cyclic. Cyclic, you see there are three carbons. So you don't have to write all the carbons and hydrogen. So each carbon, write it as a dot and join it. That's it. Like a triangle if you write, it means what? It is a cyclopropane. And it is understood that there are two hydrogen atoms. So where do we use these bond line structures? Mostly while naming the molecules and writing different isomers. So again, what are these isomers? That we will be discussing in our next classes. Okay. So now let's see the fourth type of representation of the molecule, that is wedge-dash or three-dimensional structures. The three-dimensional structure of organic molecules can be represented using wedge-dash structures. That's why it's also called as 3D structures. The 3D structures of organic molecules can be represented on paper by using certain conventions. A solid wedge, something like this, right? A solid wedge is used to indicate a bond projecting out of the plane of the paper towards the observer. This is above the plane. The dashed wedge, something like this, right? This is used to depict the bond projecting out of the plane of the paper and away from the observer. That means below the plane. Let's take example of methane molecule. In methane, the carbon is sp3 hybridized. Therefore, it is tetrahedral. In tetrahedral molecule, the two bonds will be in the plane, right? So these two hydrogens are in the plane and one is above the plane. The above the plane, that is represented as a solid wedge like this, right? The other one is below the plane. The other hydrogen is below the plane. And this is a dashed wedge. That's why this is also called as wedge-dash structure. This is how we represent different molecules. Now what we will do, we'll solve some interesting examples to understand the representation of different organic molecules. Students, observe the molecules given here and in what representation they are present. Since all the atoms and bonds are shown here, that means they are complete structures of the molecules. Now what we will do, we'll convert them to condensed structure followed by the bond-like structures. How to write the condensed structures? You cluster the atoms or club the atoms, right? CH3. Then we have CH. Since it is attached to heteroatom bromine, it's better to show a bond between them. And again, we have CH2, CH2, CH. It is attached to heteroatom chlorine and then CH3. This molecule can also be represented as, in some of the books, they usually write like this, bromine in the bracket. Okay, showing that it is attached to the second carbon. The rest of the molecule, it's same except for this part, wherein again the chlorine is written in the bracket like this. Okay, this is also correct. Either like this or like this. Now, how to write bond line structures? Count the number of carbons here. There are 6 carbons. So 1, 2, 3, 4, 5, 6 in a zigzag fashion. And then join the bonds like this. Now, on the second position, there is a bromine. You have to show the bond between them. And then we have CH2, CH2, CHCl. Here, there is one more heteroatom. It's better to show that also. So, this is the bond line structure of the molecule. Now, let's move on to the second molecule, wherein nitrogen is the heteroatom. You see it is attached to one methyl here, that is CH3, and one more CH3 here. And then, what about here? We have CH2, CH2, CH3. Or there is one more way of writing the molecule. How to do that? You see there are two methyl groups, right? So CH3 twice you can write like this, and then CH2, CH2, CH3. This is also correct way of writing the molecule. Then how to write the bond line structure? Very simple. You write down the nitrogen. You have to write the heteroatom since it is attached to two methyl. So one here, one here. It's understood, okay, because there is one carbon here. And what about here? There are 3 carbons. So 1, 2, 3. So this is the simple bond line structure of the given molecule. I hope I made this representation of organic molecules concept clear to you. And if you still have any doubts, you can comment them in the comment section. In the next lecture, let's see how to classify the organic molecules with examples. Thank you for watching this video. Until next time.